Okay, so let's get into the nitty-gritty of these particle systems here. So as I said before, the particle system is going to be made up of 3 classes. So we have our main class, which is our driver class. It's the one that's going to own all of the individual emitters and whatnot. So you can see that in this case, I have it owning one emitter, and it's going to be called test. Now yours could have as many as you want. I just called it test because it's going to be a test emitter. You're going to see this in the program itself. Now, I have 2 sprite sheets. In X and A, those are texture 2D objects. I'm just doing both in one video here so I can reuse the video as much as possible. But in any case, so you're going to have 2 image variables, one for the particle and one for the emitter. So the emitter, it doesn't have to actually have, you don't actually have to have this. So the way that I've set this up is if you don't want to supply an image for the emitter, you don't have to. So for example, in the example of the firecracker, there's no necessary emitter itself. There may actually just be a point, in which case that's fine. So you just wouldn't draw it. So when we specify this, you're actually allowed to enter a value of null for an emitter image, and that's okay. The particle image, it needs that. That is actually a necessity. So you need to draw something in the place of a particle. There needs to be some image. Now it could be a simple 1x1 pixel box. That's fine. Or it could be something more complex. It could even be an animated sprite sheet that actually is animating throughout the whole process. That's fine, no big deal. So maybe like each individual particle is an explosion in and of itself, or maybe it's like a little animation of changing colors or something like that to simulate some effect. It's up to you. A sprite sheet is a sprite sheet is a sprite sheet. Nothing changes there. Now in X and A, we don't really have the animated texture 2D, so it's just a static image, so you would have to do some extra coding to get that animating on your side, but you know, it's fine. So as I said, it's going to be made up of 3 classes. So we have our main driver class, which is the world, like what actually owns everything. That thing is made up of an emitter, and the emitter, as you can see here, has a lot of different parts to it. We're going to come back to this one. The one thing I did want to note that it is made up of particles. So in Java we have an array list of particles. In X and A or C#, we're going to have a list of particles. If you knew exactly how many particles you had, you could also use just an array as opposed to an array list or a list or anything like that. It's up to you how you want to go about that, but I'd like to use the expandable version just because it simplifies other things later on down the line, depending on what you're going to do with it. So the main is made up of emitters. The emitter is made up of particles. Okay, and many particles. Now I'm just going to leave the emitter for now. We're going to come back to that. We're going to go over to the particle class. Now this particle class, remember, the top piece is the name, the middle piece here is all the variables that we're going to be using, and the bottom piece is all the functionality that we're going to be implementing. You can see there's a lot of functionality going on in this particle. Particles do a lot. Now what you need to realize, and this is the very most important piece, a particle is just a projectile. So basically all of this you see here, that's projectile data. That's the same stuff that we had when we did a simple projectile in the demo before. I've duplicated some values for the cycling of particles, like for example these values right here and this one right here. These are duplicates, and the reason being is what's going to happen is when the particle dies, we need to reset it. So I need to set it back to its original start position and start trajectory and start forces, so we don't have to recalculate them every single time, because particle systems can be very expensive depending on how many particles you have, and then they're even more expensive if you decide to do collision as well. So you have to be very mindful of all this kind of stuff and take any shortcuts that you possibly can. I know it seems a little bit cumbersome, but that's the way it's got to be. You need to save space and time whenever you possibly can. So these 3 here and this start transparency value, these are going to be duplicated data at the very beginning, and then they're going to be called upon whenever we want to reset the particle itself. Other than that, all the data is exactly the same as a regular projectile, with the exception of these last 2, lifespan and life spent. Lifespan is how long the particle will be alive after it's launched, and this is measured in milliseconds. So like 1,000 milliseconds is 1 second. So if you want it to live for 3.5 seconds, then its lifespan would be 3,500. Life spent is how much time it's actually been alive since it's been launched. And basically every time it's updated, it checks to see, it adds in the next amount of time, and it says, has that time exceeded lifespan? If it has, die or reset, whatever, depending on what whatever the setup is for your system. So this is all the basic data. And again, down here we have all the same data that we have for a regular projectile, with a few extra ones to handle things like recycling the particles and whatnot. But I've basically cut and pasted most of the code from the original projectile code and just added a few tweaks here. It's quite a bit of the same stuff. So let's get into the code and start breaking it down. That'll be the next video, now that I've covered what's made up of... actually, you know what? Let's quickly talk about the emitter before I get into the actual code. So the particle, as I said, is just a projectile. And on the other side, the emitter, which owns the projectiles, each particle itself, it has all of its own data. So basically the purpose of an emitter is to launch particles. So we create the emitter, and when we're ready we start the emitter using the start program, and that will start launching particles. How many particles? How often? Well, that's what launch frequency is. Launch frequency says every amount of time launch this many particles, and keep doing so as long as I still have particles to launch. And after I'm all done, stop emitting, that kind of thing. Now there's a whole bunch of data that needs to be set up so we can create each individual particles and give them some chaos. The particles need to be chaotic, because if they're all the same, what happens is you look at, like, if it's like an explosion, it might be like a perfect ring. That's not very realistic. So by adding a little randomness and chaos into the mix, we can create a more realistic situation. So for example, what we're going to do when we create an emitter, we're going to create a few range values that allow us to add that chaos in. So gravity and wind are going to be pretty standard for the whole emitter. That's fine. However, we're going to have a low angle and a high angle. So that means, like, we want to launch all of our particles between these two angles. So for example, if we wanted to launch it up like a volcano, we might want to launch it between 45 and 135 degrees. And when we create each particle, we're going to randomize its angle between those two values. So it might be like 78 degrees or something like that. Similarly speaking, we're going to have a low speed and a high speed. And this is the number of pixels it will move in 1 second. So it'll go at that angle and move this many pixels. And again, you can specify whatever speed you want. Maybe it's between like 10 and 500 pixels per second. Your choice. And then we have the same thing for lifespan. If they all died at the exact same time, it would look awkward, because they would just all vanish. It wouldn't make any sense. But if they all die at their own timing, all of a sudden you get a system that looks unique and chaotic. So that gives us a little bit more flexibility. There's a few other variables up here that we take that we're going to need. So for example, the particle width and particle height. The particle should and most likely is not the same size as the emitter image itself. So usually it might be like smaller. So for example, if I have a water fountain, the water fountain might be the emitter, but the image for it, each individual water particle is actually quite a bit smaller. It might be like a 3x3 pixel or something, or 3x3 image or something like that. Something a little bit tiny. The variables up here. Time passed, that's just for how much time has passed since the last time the whole setup was updated and whatnot. Particles dead, particles alive. This is used in the idea of recycling the particles. How many particles have died, how many particles are still alive, and then using this value we can see how many particles have not been launched yet. All right, so particles dead plus particles alive, that value should be less than or equal to num particles. Right, so we can use that information during our launch process. This launch Boolean just tells us whether we've launched all the particles. This is used for explosion type particle systems, and the idea is that we set this to true once we've exploded, so the next time it gets to it in the update, it doesn't try to explode them again. Otherwise we create a process that doesn't do what we expect it to do. And that's pretty much everything for an emitter. It has basic functionality, things like update, draw, start, reset the particle system, launch particles, however many particles we want to launch at that time. So we'll be launching particles per launch. Set position, so this allows us to move the emitter if we want. So I'm going to demonstrate how we can create a particle system that follows the mouse. So it creates like a particle system that trails along with the mouse, which is a pretty cool effect. And then get particle launch point. This is a really interesting thing. You may not want to do this in yours, but I've chosen to do it because I like it. So basically what it does is it takes your emitter image and its destination rectangle, and it says, where's the center point for that? Alright, now line up the center point for the particles on that same center point. And then that way we can calculate where the particles should launch from, and that way it actually looks like the particles launch from the very center of the emitter, which is really good for things like explosions or whatnot. Otherwise they'll be launching from like the top left corner of the emitter, which could look pretty awkward and not give you what you expect to get. So in the end, we're going to try and produce something like this. Now this is an example of an explosive particle system, and it's going to explode wherever my mouse is. Now again, you're looking at a video that's running at 10 FPS, so it probably looks pretty choppy to you, but it's pretty smooth on my end. So in the next video, we're going to start breaking down the individual classes and show you how they actually work so you can try and implement and apply them in your own programs.